Hello, good morning, good afternoon and good evening whenever you are watching the video. Today I am presenting you a handwritten digit recognitions with artificial intelligence. So before going deep into the paper, let me start with the basics of artificial intelligence. Once John McCarthy said that, who is also known as the father of artificial intelligence, AI is the science and engineering of making the intelligence machines. Like he is talking about mimicking the human intelligence simply. So AI is not a new concept, it has been in the market since late 50s. So to these days everyone is talking about the computer vision and the natural language processing. These are the emerging field for now. AI has done almost everything from surgery to disease detections and surgery to game playing and the self-driving cars. Nowadays machines are learning from the experience like humans. So what machine learning and the deep learning is? Machine learning and the deep learning are the subset of artificial intelligence. Machine learning simply learns from the data and improve themselves without being explicitly programmed. Previously, in many years back, we need to hand code everything to perform certain operations in the machine, but these days machines are learning by themselves. That's really amazing. In the deep learning, when there comes the term big data, there comes the term deep learning. So with the more amount of data, we need a deep learning algorithms. That a machine learning algorithm helps to have the better accuracy compared to the deep learning algorithm when there is a large amount of data. So we can say here is the data that in the last 2 years alone 90% of the world data has been created, and it is projected that 463 exabyte of data will be generated each day by the humans in 2025. That's a lot. So for this project, this digit recognitions, I am using Kaggle, and Kaggle is the world largest platform for machine learning in the data science projects. I have been doing Kaggle for a year now. It's a really good platform to for the data science and the machine learning beginners, intermediate or the advanced machine learners. So it provides a notebook like the Jupyter notebook or the Google Colab for free. Just to access this we need to have Kaggle account. So there start with the data preparation. MNIST, I will go with the MNIST now. MNIST is a handwritten dataset. This is dataset. MNIST has 6,000 examples of training set, 60,000 examples of the training set, and the 10,000 examples of the testing set. Data can be directly downloaded from here. We have training set, training levels, and the test set and the test levels. And the other information can be found in this website in here. So back into the paper. So it is said that the details descriptions of the data is also given in the Kaggle. Like here is the data. We can read the overview of the data here, the data itself. So we can see here that each column is 28 into 28 pixels. So 28 into 28 is 784 pixels in total. And these are handwritten. So the pixel values ranges from 0 to 255. The more the darker, the more the value of the pixel will be high. So we have training data set as 785 columns. That means training data has the level column, that makes to 785, and the test set has 784 columns which do not include the level. So I will describe it in a paper as well. Here 785 columns including levels, 784 columns excluding levels in the test set. So simply loading the data by using the pandas read CSV function. It's easy. Looking at the first 5 rows of the training data, we can see that there is a level column. This is a picture. Real pictures are stored in the level columns, and these are the pixel values. And the same goes for the test set as well. Their level column is missing and the other is same. So by using pandas shape functions, we can see the shape of our data set. Training the shape of training set is 42,000, and the 42,000 rows and 785 columns, and the test set have 28,000 rows and 784 columns. So simply now I'm dropping this into x and y variables. Like x will contains all the pixel values, all the columns except levels, and the y will contain all the only the level values. Now time for the normalizations. It's better to do the normalizations because normalizations simply, now I'm rescaling here. The values of the pixel values lies between 0 and 255, but I want to resize them in the range between 0 and 1. So I am simply dividing by 255 to get the values in the range 0 to 1. It's because the convolutional networks even perform better in the range as compared to the values in 0 to 255. So it is better to perform the normalizations. Now reshaping. As we have seen that we have the training and the testing image with 28 into 28 pixels, right, which is the one-dimensional matrix. Now we need to convert it to the 3-dimension. 28 into height of 28, width 28, and the corner level 1. We have the image is grayscale, so we only included the one channel. If we have the RGB images, then we need to include 3 in this place of 1. That will give 3 channels. Now one hot encoding is simply converting our categorical values into numbers. That's simply easy. Initially the shape of the y is 42,000 only without including the columns, but the data is now 42,000, 10. Now splitting the data into training and the validation set using the scikit-learn train test split function. We can simply do that like x val, y train, y val 2, passing these x and y values with the test size of 0.1, which is 10%. Only 10% of the data is used for testing and the 90% is used for training. Now by using the matplotlib visualizing the data, these are the initial values in our data set, like real number is 2, 2, 0, and the 7. These are plotted simply by using the matplotlib imshow function. Now it's time for training the model. Convolutional neural network is used for training the model. Convolutional neural network is a deep learning algorithm that takes an input image, assign the importance, and able to distinguish the image from one another. So here this is our model definitions. Kera sequential model is used while modeling, in which only one layer can be added at a time. In this case, the first layer is a convolutional 2D layer. This one is the convolutional 2D layer with filter 64s, kernel size 33, and the activation function is the ReLU. Convolutional 2D layer, this is the first layer. First layer has 64 filters. Second 2 layers has 128 filters, and the third layer has the 256 filters down here. And the second is a max pooling layer. Max pooling 2D layer, which is the second layer of the model. It simply downsamples the input representation. Pool size is 2 here. Pool size is 2, so it looks at the 2 nearby pixels and picks the highest value. Max pooling layer. Now comes to we have discussed about this. Now comes to flatten layer. Flatten layer is used to convert data into 1D layer, 1D array of inputting the next layer. So it will simply convert the data into 1D array. Now the fully connected two dense layers are used here, down here, with the ReLU activation functions. ReLU is nothing but a rectified linear unit, which that is linear for all positive values and the 0 for all negative values. That's simple. And compile with loss optimizer and the matrices. Cross entropy as a loss. That loss function simply measures the model error with known levels. Optimizer is an add-on functions that is used to change the attribute of neural network in order to reduce the losses, and the matrix accuracy is finding the performance of the model. Now training the model with the data augmentations. The model is trained with data augmentations and without data augmentations. At first, I am training the model with data augmentations by passing simply x or y trained data, and the batch size is 64 and the epoch is 5 epochs for now. And the validation data is the x validation and the y validations data. we can see that the training accuracy is 0.99.23, which is 99.23%, and the validation accuracy is 98.86%. That's a really good accuracy. And without data augmentations, with data augmentations, model is also trained. While doing the data augmentations, randomly rotating some training image by 10 degrees down here, then zooming the image, training the images by 10%, randomly shifting the images horizontally by 10% of the width, and randomly shifting the vertically by 10% of the height. So with the data augmentations, we see the accuracy of 99.505% and the validation accuracy at 98.85%. Almost the accuracies are same in both cases, so I try to do it with the two methods as well. Data augmentation is mainly done when maintained to minimize the overfitting problem. So now evaluating the model. While evaluating the model, like training and the validation accuracies are plotted. The more the number of epochs increases, the training data validations also, training and the validation accuracy also increases in this case. And in here, training loss and the validation loss are plotted. The increase in the epoch size increases the decreases the validations and the training loss as well. Now plotting the confusion matrix by using the heat map SNS C1. Here we can see that in most cases our model is predicting the getting the right decision, but in some of the cases, like in here there is the 5, this is the error. Like the true values is 7, but our model is predicting 1 for the 5 time. That's 1 error. And here is the 4th. The true value is 4, but the model is predicting 9 for the 4th time. This is the another error. Simply confusion matrix is used to measure the performance of the machine learning classification problem. So predicting, we have already predicted, so plotting the values in the using the matplotlib. So we can say that the real value is 3 and the predicted value is 3. That's accurate. Almost everything is accurate here, like 11771110. So our model is 99% plus accuracy, so it's predicting quite accurately. Now in conclusions, we have trained the 5-layer sequential model, convolutional neural networks having 99% plus of accuracy. The model is trained with the Core i3 5005U CPU in 10 minutes and 12 seconds. It can be trained with the GPU and TPU in the Kaggle or the Collab. Rather, I choose to do in the CPU because the epoch size kept was quite less. So that's it from the paper. Thank you.